Hi, we're going to present the main features of EMF Parsley, an Eclipse project. My name is Lorenzo Bettini. I'm a professor at the University of Florence, and the other committers of Parsley are Vincenzo Caselli and Francesco Guideri, who are working at RCP Vision, an Italian company based on EMF technologies and Eclipse technologies in general. So, what is EMF Parsley? It's a framework for easily building a user interface based on EMF models. We provide some built-in UI components that you can use in your applications with easy customizations for all these components, especially if you use the DSL we provide. And we think it's very lightweight and straightforward to use in any existing applications. The main peculiarities of Parsley is that customization is not based on extension point mechanism, but on dependency injection, because we think it's easier to use dependency injection to consistently customize all the features of the applications. We basically use the same dependency injection mechanisms as in Xtext. So if you're familiar with that, we use the same mechanisms. The DSL is completely integrated with Eclipse JDT and with Java, and it provides a static type system. We generate code for the customizations, and everything is completely customized, debuggable. So we are not based on a reflective approach. And the idea is that it should be really easy with existing Eclipse API to just put your components implemented with Parsley in an existing application. So this is just a brief overview of the components that we already ship with Parsley: trees, tables, forms, combinations of them, and dialogues. And all these components are provided with the Java APIs. We also provide a few views that you can already use in your applications, and you can also see these views as some reference implementations on how to use the Java API of Parsley. We provide project wizards with some initial templates to get started, many examples to import, and a rich Eclipse tooling for the DSL. So some motivations, if you're familiar with EMF and you use that directly, you know that you have to write lots of boilerplate code just to get started with some viewers like trees and tables. And that gets worse if you want to customize these things. You may have to write your own item provider, then write your own adaptive factory, and then connect all these things consistently in all your views. The main idea of Parsley is to hide all these details and to use another customization mechanism that's based on dependency injection. So with Parsley, instead of writing all these lines, all you have to do is inject a viewer factory, create a tree viewer with standard API, and just initialize the viewer with the factory. And that's all. And you have an already working tree based on the model. Or if you want a form, again, you inject the factory and you create, or a table, you just inject the factory and you create the table based on your EMF model, just 2 lines. And the same holds for forms. Just inject the form factory and then create the form. And again, everything is done automatically by Parsley in the background. Yeah, so we show the first demo. We import one of the examples provided by Parsley, and we see a few features. So the first example that ships with Parsley is based on the standard EMF library example. So let's see the DSL in action, and I'm going to provide more details on the DSL. We have many sections in the DSL that you can navigate with the outline. From this DSL, we generate lots of Java code for you in the gem folder, which you should not touch because we will regenerate that. Okay, we also generate the plugin XML for you based on a section of the DSL, and we don't actually regenerate the plugin XML, but we merged it. So if you do some manual customization on the plugin XML, when we regenerate the code, we actually merge the new things with the ones you provided. So let's change the title of the view, and when we hit save, we regenerate only the parts that are modified in the DSL, but we don't touch the things you generated. So let's see what we get from this configuration in the DSL. We get a tree with a form based on an EMF library model. So you get the tree. If you select an element, you get the form that's automatically rendered with all the features of that object. We have double click on the elements and we open a dialog. Similarly, we have automatic data binding, so if you change something in the form, it's automatically reflected, and this view that we provide is savable, so it gets dirty state, which is automatically handled by Parsley. The same holds for the dialog, of course. We have context menus that can be customized. Of course, these items are contributed by CDO, which is in the target platform, and you can also have your own context menu, and we also have automatic validations based on the eCore model. So there's a constraint in the library that requires the field of the author, and of course this is done lively while you're typing. Okay, and what we can see is debugging in action. So we can put a breakpoint on the DSL. So this is the part which contributes custom context menus. We can put a breakpoint, and when the breakpoint is hit, we actually debug in the DSL. Of course, you can also debug the generated Java code if you want, but everything is integrated in the Eclipse debug. So of course the variable views works. If you change the title, you can step on the DSL and you can see the new element. So everything is debuggable, and again you can debug the generated code or the DSL itself. Okay, so we can go back to the slides. So how it works? The UI is built on top of emf.edit reflective, and that's also the default behavior. So if you don't customize anything with Parsley, we simply take the default behavior of EMF edit, and if you have your own .edit project, again we use that .edit project as possible customizations. And then if you want to customize anything, you can do that in your .edit plugin, but you can also use our dependency injection mechanism. In this case, you don't have to inherit parts or inherit huge editor or form or table classes. You just concentrate on customizing a very specific aspect, and that specific aspect will be automatically and consistently injected in the whole framework. And that's done purely in Java if you want, or in the DSL, which is easier. Just another word, so since we use your .edit project, it means that you can easily gradually porting an existing EMF applications to Parsley, because you can still use .edit plugin, or if you want, you can leave a few customizations in the .edit project and do the other customizations in Parsley. So they both coexist. The EMF Parsley is DSL is implemented with Xtext and Xbase. So if you don't know Xtext and Xbase, you will see a few presentations later today. So it means that we are completely interoperable with the Java type system. It means that in the DSL you can use any existing Java libraries that are on your class path. And of course, a rich IDE tooling. You already saw the debugging in action. The idea is that you customize and configure everything in a very small, compact file, and from that file we generate all the Java code for you, including all the dependency injection mechanisms. So you don't have to worry about the dependency injection if you use the DSL. And if you want, you can write parse with the DSL and parse in purely Java, because they coexist seamlessly. So the DSL, as I said, is statically type checked, but with lots of type inference, so you don't have to write types if they can be inferred. And everything is statically type checked, so you don't risk to misspell features of EMF. And we do all this checking statically, and we also provide quick fixes in case you misspell the features. So again, you have access to all the Java types according to the project dependencies and class paths. So you just configure your project with dependencies as you usually do. The DSL elements can extend your Java class, so you can write customizations with Java and use them in the DSL, and again, everything is debuggable. Automatic imports, so just like you do with the JDT editor, you don't have to write the imports. They can be either automatically inserted or we have quick fixes for them. JDT integration, so you can hover on elements in the DSL and you can see the Java doc of the corresponding Java class. You can use again all the Java types. So when you're writing DSL, you have to use these Xbase language, which is a kind of more readable Java. But in the end, you use all the existing Java types. And there will be a talk about something similar to Xbase later today. Integrated building with clips, so you just press save and all the Java files are regenerated. You saw also the plugin XML is merged and regenerated, fully integrated in with the Eclipse building mechanism. Just press save. The customizations can be done in 3 ways, and all 3 ways work together in cooperation. So again, you can do things with your .edit project, or if you have an existing .edit project, it will continue to work with Parsley. You can use the, you can specify the customization with the DSL, and that's the easiest way because the DSL is compact. But if you want, you can use purely Java to write all the customization. And you can use these three things together. So the default behavior delegates to emf.edit. So if you don't write any customization, everything will work with just emf.edit, either reflectively or with your .edit plugin. And let's say that we want to customize a few things in this view. We don't want to show all the borrowers, video cassettes, but we only want to show the writers and the books in the contents of this tree. To do that with Parsley, there's a section in the DSL which is very small and compact, and all the customizations are specified declaratively. So you say that for the library, the children of the library will be writers and books. Again, everything here is statically typed. And what you get in the end is the custom content provider automatically injected in the viewer. Let's say that I want to customize the features that are shown in the form and also the captions used for the features. Again, there's a section, there's a section in the DSL, and again, everything is done declaratively. So for the library, I only want to show the name. For the writer, only the name, the address, and the books, and for the book, only the author and the title and the category. And again, this customization is injected in the form representation. Again, for the labels for the trees or the captions in the form, there are two specific sections. Again, everything declarative. Again, everything is statically typed, and all these book writers are the Java classes of your EMF models. And you can also write context menu, custom context menu. This can be done this way in Parsley. You have to specify, for instance, that for a writer you want a custom context menu. You specify the label for the menu, the object that will be changed by your menu, and then you specify a lambda, an X-space lambda, which contains the code that will be executed when your context menu is selected. This is purely Java EMF API written in X-space. So in this case, you want to create a book, add it to the library books, and set its title and set its author. And this element will be shown in the context menu. Again, everything automatically injected in the framework. Just by writing this block code, we will handle undo and redo automatically for you. So undo will automatically undo all these modifications that you specified in the context menu, and redo will redo them. But everything automatically, you don't have to worry about the editing domain underneath, all the undo and command stack things. They will be handled by Parsley. And this is another example. You can specify as many context menus as you want, and we will see a demo for the context menu. So let's see the second demo. We will write a few things in the DSL, and we will going to show a new feature that will be released in a few months. So one of the drawbacks of using a code generation approach is that if you want to test something, you have to run another Eclipse instance, and this is not very productive. So what we added to Parsley, it's a live preview of your modifications in the DSL. And this what it does is basically reloading dynamically all the generated Java code in your workspace, and we'll use that to render the viewers and the forms and the tables. So let's see an example. I don't have to run another Eclipse instance, and I can already see what the behavior of my view is here. If we change something in the DSL, as we will see in a minute, we just press preview and it automatically reloads everything. So let's see an example of the customization. We want to customize the content provider so that books are shown as children of authors. So we say that the children of a writer are their books. Don't run Eclipse again, just press preview and you see your customization in action. Okay? Let's see the creation of a new context menu. Again, usually you have to run another Eclipse instance, but we can test it right here. Of course, this preview is meant to be used as a quick prototype mechanism to see your customization of the behavior of the UI components. So we basically want to write an action that creates a new book in the library and sets its author as the selected author. Of course, you see that the DSL provides rich UI tooling thanks to Xtext and to Xbase. So we specify the label, we specify the object that will be modified by this custom menu, and we specify the lambda that will be executed. You see, these are all Java types. So we say that we add a new book, we create a new book. This is standard EMF Java API. So if you're familiar with EMF, you know that if you want to create an object, you have to access the instance of the factory. And even if you don't know XSpace, it should be quite easy to learn, because you don't have to write all these verbose Java code. So just set this title. Let's see the new menu in action. So let's select, and you see the new menu, which is working without running Eclipse. We also want to show that we use dependency injection not only for the behavior, but also for properties of the viewer. So let's say that I don't like the orientation of the form underneath the tree. I don't have to subclass the form and change the orientation. I just have to inject the property for the orientation with standard SWT API, and the form is now on the right. And if we want to change the, let's say, the numbers of columns of the grid layout, we just have to set a property. Again, use the content assist. Content assist is your friend to do this customization. We say 4 columns, and now the form layout will use 4 columns instead of 2. Okay. What we haven't, did we show the validation, the automatic validation support? We can show that. So if we create a new child with a book, okay, there's a, okay. Let's get back to the presentation. Parsley is fully EMF compliant, so you can use any EMF resource compliant. You can use Xtext EMF resources. You can use other EMF persistency implementations. If you have a custom editing domain, let's say for transactional editing domains, you just have to customize a few things and everything will work. And all the notification systems, undo, redo, drag and drop, will work out of the box. So you may have the standard EMF editor above, an EMF Parsley down at the bottom. If they act on the same resource, they will use the same editing domain under the hood, and you can drag and drop things between these, the standard EMF editor and our EMF Parsley. We say that it's big app friendly because everything is done in a single file, and then you just generate everything else. That project can concentrate on a specific aspect, and if you want to search things, you just use the Ctrl+Shift+F3 to see all the elements of Parsley that are used throughout all your projects in the workspace. It out of the box integrates with all the standard mechanisms, persistence mechanisms like XMI, TNEO, CDO. We have a version of Parsley which works with RAP, and you already saw this automatic integration with EMF validation. It's easy to upgrade to a new version because even if we change the runtime Java API, what you have to do is just clean the project, and the DSL compiler will regenerate all the Java code for the new version of the Java API. So you just have to update the runtime and regenerate the code. We already part of the simultaneous release, and we already have a few applications built both with RCP and RAP in production, also commercial application, and it's also easy to switch between persistency implementations because Parsley hides most of the details implementation. So if you want to switch to a standard XMI to a CDO resource, it's just a matter of changing one line of code and everything else would work. And we usually use this feature for testing purposes. So for the third demo, we will see a commercial application built with Parsley, which integrates with series diagrams. Let's see first the layout of the application. I'm going into a few details. So on the right, you see a series diagram. This application scans invoices and with an OCR mechanism tries to detect the parse of the invoice. So what we did, we customized the background of the diagram, and then we used series to highlight the blocks in the invoice that are recognized by the OCR mechanism. The position of the blocks and the detected parts of the invoice are stored in an EMF model. So the idea is that when you select something in the diagram, we have two Parsley views. So these two views are built with Parsley. There's a tree and the form that automatically synchronize with the blocks in the EMF in the series diagram. So if we select a block here, we see the corresponding one here, and so on. And so the idea is that the model says which part of the invoice are recognized. But if we change something here, let's say that we move this block, you see that the model is automatically reflected by this change. So you can reposition the parts in the invoice if the OCR mechanism failed in recognizing a few things. And this shows the integration between Parsley and series. Okay, so I think we can conclude. These are a few links. Since we have time, just very few excuse me, slides. We care about code quality. We constantly analyze our projects with SonarQube. We have quite a high percentage of code coverage, and we have zero technical debt in SonarQube. Of course, that doesn't mean that Parsley is bug-free, but we think that's a nice starting point. And if you're interested, at the Project Quality Day, there will be a talk I will give about testing Eclipse plugins, which show a few techniques that we use to easily parse all these UI parts in Parsley without using a functional testing framework. Okay, I think we're done, and there's a few time for questions. Okay, so thank you.